Continue with relative velocity. This time first, we need to actually look at the mathematical representation of relative velocity. So in the previous session, we explain or we give a particular idea of what relative velocity is generally about. But then we have to actually deal with velocity numerical value, because velocity actually is a uh, uh, quantitative value. So we can be doing using categor- categorical mean of uh, telling about relative velocity. So we need to look at how to mathematically represent relative velocity. Let's get into that. So in the let's say we have two bodies, right? Let's say body A and we have body B, and body A is moving with velocity v, let's say VA, and this is moving with velocity, let's say VB. So VA and VB, right? They have values, right? These two have values. How do we know the velocity of A relative to B? Meaning that how is B seeing A? Velocity of A relative as compared to B, right? So if you are in the place of B, right? How will B be seeing A? That's what it means. So this is how to write it. Velocity of A relative to B. So A come before the B. Take note of this thing. So if we say find the velocity of A compared to B, A comes first before the B. Find the velocity of B. Find the velocity of A relative to B is the same thing. A relative to B. So you just follow that order, right? So the mathematical representation is going to be VA minus VB. This is how to represent them mathematically. So, or if you are saying what's the if you are A, how will you be seeing B? Meaning, what's the velocity of B compared to A? Right? What's the velocity of A compared to A? So, how will A be seeing B moving? Basically, that's it. So, the representation is velocity of B compared to A, right? B come before A. Velocity of B compared to A. So, VB minus VA. This is the representation of it. Based on how the question is. It just means that if you put yourself in the shoe of one of the vehicles or one of the body, how will you be seeing the other body? If you put yourself in the shoe of one of them, how will you be seeing the other one? That's basically how it's going to be. So the cases that we are going to look at are cases like this one. So two bodies are moving, right, in the same direction. A is moving towards the east and B is also moving towards the east. And these are their velocities, 4 meters per second and 70 meters per second. Now let's put ourselves, if you are in A, right, how will you be, if you are A, if you are in the car A, how will you be seeing car B moving? So we are going to do, meaning that we are going to look at the velocity of B, right, compared to A. If you are, we are assuming that we are in A, right, and we want to see how B will be moving when we are in car A. So meaning that velocity of B compared to us in A. So velocity of B relative to A, right, is going to be VA minus VB. And this is going to be, oh, sorry, you see the mistake. Take note of that. So the bottom here, B come before A. So take note of that. VB minus VA equal to. So you see that the bottom here is B before A. So when you are writing this, right, the subtraction, make sure B come before A like this. Now velocity of B is what? 17. So 17 minus 4. 17 minus 4. What are we getting? We are getting 13 meters per second. So this means that if you are in car A, right, the person in car A will be seeing B moving with a velocity of 13 meters per second. Okay, but the actual velocity of B is what? 17. But if you're in car A is also moving with some amount of velocity, right, in the same direction. So if you're in car A, right, you'll be seeing B be moving with what? A velocity of 70 meters per second. Now, if you're in car B, how will you be seeing car A? Let's do that. If you are in, so we want the velocity of A compared to B, right? That will be VA minus VB. That will be equal to, VA means what? VA will mean VA is 4 minus VB is what? 17. Then we are getting negative 30 meters per second. So what it means is that negative means that when you are in car B, right, you'll be seeing A moving as if is going backward or is moving slowly. if you're in B, right, and you are looking at car A, if you are here, you are looking at car A, right, you'll be thinking that A is moving slowly. That's what the negative means. So you'll be seeing as if it is moving, this guy is moving backward. You'll be seeing as if this guy is moving backward because A will be seeing you moving fast, but then you'll be seeing this guy moving backward. The negative is implying that if you are in B and you are seeing A, it's as if A is slowing down or going backward or moving in the opposite direction. But actually, it's you that is moving fast. Let's have another question. So we have this sample, all of them are moving in the other direction, right? So velocity of A relative to B, meaning that we are in car B and we want to see the velocity of A, is going to be VA minus VB. If you do that, what are you going to have? VA is what? 5 minus 13, right? If you do 5 minus 13, we are getting negative 8 meters per second. Basically, it means that if you're in car B, right, you'll be seeing A moving like this. You'll be thinking A is going backward. That's how it will be. That's how the feeling will be. 80 meters per second. It's just like how when you are in a car and then say, let's say this is your car, right? This is you here, and there's a car in the front, and then your car is overtaking this one. When it's overtaking this one, and you are looking at these people, you if you don't look at yourself as moving, right, you'll be thinking these people are moving backward but actually it's you that is moving faster and then bypassing them. But if you are looking at them, you will be thinking they are moving backward because you are moving faster. So that's how it is actually portrayed. The negative tells you that the other body that you are looking at is actually moving slower or maybe backward relative to you. Okay, let's have another question. Here they are all moving downward, so the same thing. Here I want to see the velocity of B, right, as seen by A. So I'll do VB minus VA. Right, remember I'm following this trend, that trend, right? VB is what? 6 minus VA is 10. So I'm getting negative 4 meters per second. But we need to interpret what does this mean? It means that when you are in car B, right? When you are in car A, sorry, if you're in car A, you'll be seeing car B moving what? Backward with a velocity of 4 meters per second. You'll be seeing as if it is moving backward with a velocity of 4 meters per second. The backward thing is what the negative means. Or you can see it moving in the opposite direction as you. That's basically what it means. Okay, you can do the reverse. So if you are sitting in car B and then you are looking at car A, that means the velocity of A as seen by B compared to A. So we are going to basically do VA minus VB. VA is 10 minus VB, it is 6. Then you get 4. Here is positive 4. Positive 4 meaning that if you are in car B, right, you'll be seeing this guy moving forward with a 4 meters per second or moving faster with a 4 meters per second. Okay, let's solve this question. Here they are all pointing downward. Which one should we use? Should you find VA ratio of A ratio to B, or which one? So let's say VB A. I just randomly took it. So it's going to be VB minus VA. It's good that you have to write this in following this trend, right? So, but remember, this is where we are. Okay, this is the reference guy. So if you are doing this guy is the reference, right? We say reference or what? Observer. So the observer comes second. So this is like velocity of B, right, compared to A, as seen by A. A is considered to be at rest from the definition. VB is what? 4 minus 9. Then I'm getting a negative 5 meters per second. This negative 5 meters per second implies that if you're in car A, right, you'll be seeing B moving backward or the opposite direction. We are moving like this, so this guy will be seeing these people moving backward with a 5 meters per second. Meanwhile, actually, it's A that is moving faster than B. Look at this one. Look at this case, right? So let's say velocity of A to B relative to B is going to be VA minus VB as usual. But look at something. The guy we are referring to is where he's moving like this, right? So he's moving like this, which is 4 minus. But then actually, this guy is moving opposite already. It is already opposite in direction to this guy already. You get that? First, the previous examples, you see they were all moving in the same example. So whoever we take, right, the other one follow the same direction. This guy to follow this, they follow the same direction. But when you come here, we are doing velocity of A relative to B. So velocity of A itself, right, will be positive, which is 4 minus. But the other one that is the observer, right, is having an arrow that is in opposite direction to this. to account for that opposite direction that it is having compared to the actual thing that we want to look at, we have to bring a negative in front of it. You get this negative is counting for the original state, the original direction that is following. If it is following the same direction as this guy, no problem. So there's this negative will not come. That's like how we did so earlier. But this guy, when we want to look at the velocity of this one, which is VA, right? It's always positive here. The first one is always positive. But then the other minus, this minus is always there. This minus is always there. But then this minus that is coming now is because when you look at this condition, right? This guy is already moving in the opposite direction. To account for that opposite direction that is moving originally, right? We need to actually bring this negative. So this is what happens when the thing is the observer is moving in opposite direction to whatever we have. So it's going to be 4 minus minus become plus 17. That will give us 21 meters per second. So meaning that if you are in car A, right? If you are in car B, and you are seeing car A, right? The car B will be moving with a velocity of 20. Car A will be moving with a velocity of 21 meters per second. But meanwhile, actually, car A is just simply moving with 4 meters per second. But relatively, if you compare it to yourself, because you're also moving, the thing will just sum up. This is the case where your car is moving like this on the road, right? Let's say Accra motorway, right? Accra motorway highway, that highway. So this guy, you are here, maybe you are in this car, right? When you are moving like this and a car pass by, you see the speed, you see this how do you call it? How fast it just passed by you, you even hear the sound, right? That's because of this relative velocity. The two of your velocities at that point sum up. So the two of you see yourself as moving with very high speed. Yes. Let's look at this one. Here is a downward thing. So here I'll do velocity of VB A. So velocity of B relative to A, right? So it's going to be, so B, because they are moving in opposite direction, right? The VB minus VA. VB is what? 4, right? This guy is always positive. Minus, but then this guy is already moving opposite direction to our distance, so we have to bring a negative. The negative is telling us this second negative that we are putting inside the bracket is not this one. This guy is always here, but this negative is because this guy is moving opposite, direct opposite to our A. So therefore we need to bring this negative. And what the velocity of A is 9, right? So it's going to be 4 plus 9, which is 30 meters per second. Yeah, this is the case for solving for parallel velocities. So the velocities are all parallel. They are all parallel. They are not inclined at any angle. There's no case that they are going to meet. They are all moving straight, right? So you see all the examples earlier. They are all straight. They are all parallel velocities that we are exploring, right? This is how to simply do the VA minus VB relative to whatever they want you to do. So try to identify your observer. Remember, the observer is the one that comes last, and then the actual velocity that you want to see, you want to compare, it comes first, then it becomes VB first, always positive minus VA, and then the VA become negative inherently when it is opposite to whatever you want to observe or whatever you want to compare with. If this guy is opposite to the first one, right, then you have to bring this negative, which we did over here. But in the cases of this one, they are all moving the same direction. So when we reach this particular one, for example, this is a natural negative that comes with the formula. The negative that is in the formula. But this guy doesn't have an inherent negative because it is moving in the same direction. If it's the same direction, you don't need to sum up anything or include any negative. Yes. This is it. So now, future cases in the subsequent video, we are going to look at cases where the velocities are inclined. They are no more parallel. They are now inclined. How do you find the relative velocity? The very basic inclination that we'll be looking at is when they are inclined at an angle of 90 degrees. That's the basic ones that we have to see. Yeah. Prerequisites for that video will be you understanding the previous sessions. That's summing up velocities, summing up vectors. That's rectangle law and cosine rules and all that will be needed over there. So revise those one and join me in the next session where we explore relative velocity of inclined vectors starting with 90 degrees.